So our next section is about analyzing categorical data. And the first thing I want to emphasize is that whenever you're making any sort of distribution or graph, you always must remember to label. So that means give it a title, and it means to also, if you have units, write down what they are. It's really important that you don't forget this, because otherwise people looking at it will have no idea what you're talking about. Also, if you are in the AP class and you're taking the AP test, this is like the #1 thing that really good stats students miss is the labeling. So you don't want to miss that. It's something easy that you should never lose points on, and you'll also lose points in my class, whether you're taking the AP test or not. And I gave you a list of a few things that you can use to make a display of categorical variables. I will show you all of these 5, and you'll see examples of all of them in the class, but this is a good overview of the things that you can use. So we're going to start right away with an example, and I gave you the percentages of 12 to 17-year-olds who post various types of personal information on social media. We are going to make a bar graph to display this data. So in order to make a bar graph, you're going to start out by making a horizontal and a vertical axis, and you're going to start by labeling. So on your horizontal axis, you're going to put your type of information, and on the vertical axis, we're going to put the percent who posted. And when you're working with something of this type, with a bar graph, you're always going to want to start with 0, especially if you're working with percentages. Otherwise, it'll give you a weird and crazy graph that will give you something wrong, and it will be misleading to others that look at it. So I'm going to start at 0, and you can go by like 10s, you can go by 20s. I'm going to be really lazy and go by 50s, that's fine. And from there, you're just going to draw your bars. And I'm going to start with the people that do a photo of themselves. You can just kind of estimate where it is. So that looks like it's about 91. And you're going to go from there. For a bar graph, you'll find the bars do not touch. You're going to see something later on where we have what's called a histogram, and in that the bars are going to touch. But in this case, you're going to have the bars a bit spaced out. So I'm thinking you guys have probably mostly seen this stuff, whether it be in previous math classes or in the newspaper or online or something like that. So I'm hoping that this one is fairly straightforward, because some of the other ones are a little bit harder. So now, the next thing I was asking you is it appropriate to make a pie chart for this? I'm going to actually add this on this side. So a pie chart, you have probably seen, it looks like a circle, and it has sections split off. My pie chart right now is not very good, but the key thing about pie charts is you always have parts of a whole, which means that if you have percentages, they're all going to add up to 100. You might notice that here we have percentages, which is great, but they do not add up to 100. The reason is because there are many people who have photos of themselves and also have their school name or their city or town. So it's important that you know that pie charts only work if every single person can only be part of one category. So in this case, it is not appropriate. So now I have a few definitions. You don't really need to memorize what the definitions are. You just kind of need to know how to use them. So the first one is the marginal distribution. So before you understand marginal distribution, I'm going to actually explain what a two-way table is. If you see the example below, you will see what we call a two-way table. And a two-way table is going to have two categorical variables. So our two categorical variables, I'm going to actually answer question A for you, are age and cell phone type. So what the marginal distribution is if you look at one of the margins, for example, the margin over here with the totals of all the cell phones, if you look at that, the marginal distribution is going to be the percent of people in each category. So what I mean for that one is, and I'm going to actually do the problem for you and show you what it is that for the iPhone, you are going to have 467 out of 2024, which is 23%. And then for the Android, you're going to do the same thing. You're going to get 503 out of 2024%, which ends up giving you approximately 25%. Note that I'm just rounding here. And for the other, you are going to do the same thing. You'll find out that it is going to be about 52%. So the marginal distribution is going to be the percent of people that fall into each of those categories. So we know that we're using the margin on the right-hand side and not on the bottom because they're asking about type of cell phone. So what I did was I looked at all the different types of cell phones and I looked to see which percent of each type owned it. So our next vocab word is conditional distribution. And we're going to do the example that goes with that one too. So what a conditional distribution is when you know one thing about people, we want to know what percentages fall into each category from there. So in this one, for part D, I ask you for the conditional distribution of cell phone type for the 18 to 34-year-olds. So in this case, my condition is that I know that these people are 18 to 34. Honestly, for this question, I don't care about any of the other info in that table. All I'm looking at is the 18 to 34. So now what I'm going to do, to find my conditional distribution, I am going to find the percentages of each type. So starting with the iPhone, I know that it's 163 over 517, which gives me 33%. For the Android, I end up getting 214 over 517, which gives me 41%. For other, I will end up doing the same thing. I get 26%. So this gives me the nice conditional distribution. Now, what I can actually do is I am going to look at this data that I have and look to see if there is evidence of a difference in the distribution for all three age groups. I'm going to do that by making a side-by-side bar chart. So unfortunately, this requires a lot of work. You're honestly not going to be doing this that often. You might do it once on a test or a quiz. Even then, it probably won't be this long. But in order to do part E, I need to find the conditional distribution for all of the age groups. So I'm going to go back here, erase what I crossed out because now I actually need that stuff, unfortunately. So what I'm going to do is I am going to do a bar chart, but now my bar chart is going to have separate groups. So I'm just going to go on my vertical axis, I am going to have the percent in each category. And on my horizontal axis, I'm going to have age category. So my 3 age categories are going to be 18 to 34 and 35 to 54 and 55 plus. So now that I have those, I have to do a side-by-side bar chart. And I already have the data for 18 to 34. So for that, I know that the iPhone is 33%. So what I'm going to do is I'm going to use a separate color for iPhone. I'm going to make it pink. And put that in at 33%. Do the same thing for the Android and the other. And try to estimate as best you can. So the Android is about 41. The other, I'm going to make it blue. And that's about 26. So this is what it looks like for 18 to 34-year-olds. So the way that you will fill the rest of this chart in is by doing the conditional distribution for the other 2 groups. So it takes a while to do it. I'm actually going to just let you try it on your own if you want to, but I'll draw kind of a basic idea of what it looks like. And you'll actually find that already I did not draw this to scale very well, but hopefully yours looks a little better than mine. One thing you can do before you actually draw it is on your percent scale, you don't actually have to go up to 100 because you'll find the highest one that I have is going to be approximately like 70 to 80% in the 55 plus category for others. So if you only want to go up to 80 or something, that's fine on this type. However, since I made it already, I'm just going to continue doing what I have. So this is a good way to visualize a difference in distributions. And what I mean by a difference in distribution is look to see if there's any cases where the bar heights are different. The one that I would personally clearly see, and probably you notice, is that in the 55 plus category, there is a lot of people who have other types of cell phones. So there's not so much of that in the 2 younger crowds, but the older crowd definitely has more other. You can also try to look at like the other 2 categories, iPhone and Android. You'll find that the younger people do prefer them. So it's important to look at that, and you can kind of look and see what the differences actually are. So the last thing I asked you on this paper is there an association between age and cell phone type? And what that means is, this is kind of a fancy way to say, is there a relationship between them? And we'll find other ways to kind of analyze this later on, but for now, the one way that we have to do it is to look at things like bar charts. So in this case, we will say that there is a relationship because we know that older people will say yes. Older people tend to prefer other types of phones, whereas younger people prefer iPhones and Androids.